So till now in our examples we have seen some variables, and what is a variable is it is going to hold some data, right? Now what type of data each variable can hold, and what are the type of operations we can do on it, that depends on what is the type of the variable, right? That is why we shall see what are the different types a variable can be taking, which means a variable can be declared as, right? For example, there can be variables of type character, there can be variables of type integer, there can be variables of type float, of type double. Generally all the variables, they start with a name which is a character, which should not be a number, right? So in the variable names you can use the characters, the alphabets you can use, or you can use the numbers, or you can use underscore, which means you can use anything from A to Z and capital A to capital Z and 0 to 9 and underscore in order to name a variable. But there are few rules here. Now always the name of a variable should start with either this set or this set, which means either from small a to small z or capital A to capital Z. It should not start with 0 to 9 or underscore. Now in between you can have 0 to 9 and underscores, they are allowed. Okay, now these are the small rules that you might have to remember coming to a variable. Now you should always know what is the type of the variable, because depending on the type of the variable you know what are the type of operations you can perform on it, right? So let's see what are the types basic types that C programming language has given us. Now first one is char. A char is simply a single byte which is used to represent generally a character, and in most of the machines it is always 1 byte, right? And it can hold from 0 to 255. With 8 bits you can hold numbers from 0 to 255, and each decimal number will be encoded as a digit, it will be encoded as a character, got it? And then integer is generally used to represent an integer. int is used to represent an integer, and the size of this is machine dependent and your compiler dependent. Now what is the hardware you are working on and what is the compiler that you are using, depending on the properties, these two, this size will depend on it. And float is generally a single precision floating point number, and double is generally double precision floating point number. As you know, in order to represent single precision floating point number you should have at least 32 bits, right? And then some machines might go beyond 32, but you are supposed to have at least 32 bits. And in a double precision floating point number at least 64 bits are required, and some machines can have beyond that, but then these are the minimum number of bits that you are supposed to have. Okay, now apart from this, if you are going to add these quantifiers, then the sizes can vary depending on the machine you are working on. Again, it is implementation dependent, right? So there is nothing like a constant here. Now if you want to know exactly in your machine what is the size of char, what is the size of int, float and double, you can use an operator size of. So C has an operator called as size of, just like plus, minus and star. This is also an operator, right? Size of. If you give, let us say, int, and if you put it in printf percentile d size of int, then you are going to see how many bytes is integer data type taking in your system. Using that size of, you can find out size of char, int, float and double in your computer. Okay, and then we have quantifiers. Now when you are going to use these quantifiers, generally these short and long are the quantifiers which are going to be used along with the int, which means you can say short int, right? Or you can say long int. Generally when you write int, it is going to have some size, and short int is going to have some size, and long int is going to have some size, and your int typically is supposed to have a size between these two, right? Which means you can directly use, without using int also, you can directly use short in order to declare a variable. You can say short sh, or you can write short int sh, long sh, long, let us say long I or long int I, then that variable I will be long. Typically the relationship between these three are supposed to be like this, which means short is supposed to be shorter than or equal to int, and long is supposed to be longer than the size of int. right? In most of the computers, short will contain, let's say if int is containing 16 bits, short will contain 8 bits and long will contain 32 bits. But again, this is all implementation dependent, right? So again, in your computer, if you want to see what is the size of short long, you can use size of and you find it out. Okay, and similarly we can use unsigned and signed as qualifiers. Now these unsigned and signed are used generally for integers and character types. Right, now what is the meaning of this unsigned and signed is, if you are going to use unsigned int, let us say if you write something as unsigned int I, then the meaning is, if int is of size, let us say 16 bits or let us say 8 bits, if the size of int is 8 bits, then the number of values it can hold are all unsigned numbers, and so they will start from 0 and end at 255, right? In case if it is a signed int, by default int means signed int, right? So in that case what happens is, the range, if it is 8 bits, is going to be from -128 to 127. Got it? This is the range. Now depending on how you write it, either unsigned or signed, the range is going to vary. Got it? And char is generally unsigned only, right? And we generally don't have signed char. I mean, we generally don't use that way. So unsigned char only we use it. And similarly, if you want to have numbers, floating point numbers which are larger than double, some implementations will use long double, right? So which means this long qualifier will be used with double, then it is supposed to provide you with much greater precision. Maybe you might have 128 bits in that case. But anyway, everything that we have discussed here is all system dependent and compiler dependent, right? And their sizes will be actually constants which are declared here. If you want to see what their sizes are, you can get into these files limits.h or float.h and you can see it, or simply you can write a program and you can see it using size of operator. Okay, fine.